Assalamualaikum and good day everyone. I'm Mujahidi Salik, report number 27. The topic that I'm going to discuss is about elastic shortening of concrete, or ES. First and foremost, I would like to talk about what is elasticity. So elasticity is a property of material, and every material exhibits this property. So as we all know that there's no perfectly rigid body exists in this universe, and everybody possesses elasticity, and by virtue of it, it will undergo some deformation due to the compression. So I made a scenario here to understand more about elasticity. A concrete will go somewhat deformation due to the applied compression, and this deformation will lead to the loss of strain in stressed tendons. So now let us discuss all of those causes individually. So let us start with the elastic shortening of concrete, which is usually designated as ES. What is elastic shortening of concrete? Concrete shortens when a compressive or pre-stressing force is applied. As the tendons that are bonded to the adjacent concrete simultaneously shortens, they lose part of the pre-stressing force that they carry. That is the reason bakit mag-occur ang pre-stressing loss due to the elastic shortening of concrete when a concrete experiences shortening. So again, kapag ang pre-stressing force ay inilipat or inapply mula sa pre-stressing reinforcement papunta sa concrete elements, magko-compress ang concrete, thereby experiencing what we called shortening. And dahil nga ang pre-stressing reinforcement ay nakaidikit sa concrete, the shortening na ma-experience ng concrete ay ma-experience din ng pre-stressing reinforcement. Say for instance, kapag mag-compress ang concrete, magko-compress din ang bakal dahil magadikit lang sila. So dahil sa shortening na ma-experience or na-experience ng pre-stressing reinforcement, maglo-lose siya ng part ng pre-stressing force na kinikerry nito. To illustrate the methods to compute for the multitude of the pre-stress loss due to elastic shortening of concrete, let's start for the case of pre-tensioned elements. Sa figure na to, makikita natin na itong pre-stressing reinforcement ay nakat na siya. Therefore, ang pre-stressing force is i-transfer pa lang from the pre-stressing reinforcement to the concrete element. So, makikita rin natin dito na ang concrete element is fully supported pa lang siya throughout the length. So let us just consider the length of the concrete element as length, or L. Kapag na-transfer na ang pre-stressing force sa concrete element, take note of this, hindi siya equal sa jacking force nito, but a multitude lesser in value compared sa jacking force itself. Kasi ang pre-stressing reinforcement ay nakaka-experience na siya ng tinatawag nating relaxation. So ang relaxation naman is another cause ng pre-stress loss. Dahil sa relaxation na na-experience ng pre-stressing reinforcement, ang pre-stressing reinforcement tends to lose part of the pre-stressing force na kinikerry nito. So usually, we designate the loss due to that relaxation as equal to the expression na nasa ating figure. Itong delta P sub R from the time of jacking to the time of transfer. So, kapag ang pre-stressing force is matransfer na siya sa concrete element, ang tendency nito is ang concrete element is mag-bend siya ng upward, thereby experiencing what we called camber. And kapag ma-experience na nito ang camber, it will now behave like a simple supported beam. In that case, kapag ang pre-stressing force ay matransfer na sa concrete element, magko-compress ang concrete at magkaroon ng shortening like this. With the total magnitude ng shortening na ma-experience ng concrete is equal to delta ES or deformation due to the elastic shortening of concrete. So, kapag i-divide natin ang total shortening equally from both end of the concrete element, ang amount ng shortening na na-experience ng concrete sa left side is kalahati ng total shortening at same magnitude sa kabilang end. Kapag i-sum up natin ang total shortening na na-experience ng concrete, it will sum up to delta ES, then i-multiply natin by 2 since equal sila in the illustration. When the concrete element shortens dahil sa compressive force applied by the prestressing and reinforcement, at kapag mag-loss na siya ng part, ang prestressing force na kinicarry nito, starting from the magnitude here, the resulting magnitude ng prestressing force kapag deducted na ang prestress loss due to the elastic shortening is now what we call the initial prestressing force or PI. So, yan ang magnitude ng force that we usually use sa ating stress acting on the concrete element starting from the initial prestressing at transfer to the initial prestressing at transfer with self-weight. So, if we will investigate the two materials here, the concrete and the prestressing reinforcement, let's start with the concrete. So, we can recall from mechanics of deformable bodies that strain is equal to deformation over length. So, in the case of concrete, ang strain na na-experience ng concrete, let us just call it as strain due to the elastic shortening of concrete, and that strain ay equal siya sa deformation ng concrete, which is itong delta ES or the total deformation divided by the total length of the concrete. So, yan ang relationship between strain, the actual deformation, and the length of the concrete at it shortens. Since ina-assume natin ang concrete at this particular stage of prestressing operations, ina-assume natin na ang concrete ay elastic. Therefore, pwede natin gamitin or magamit ang equation ng Hooke's law, this one, which just states that the stress is just proportional to the strain na na-experience ng concrete, wherein the concept of proportionality is the modulus of elasticity E. So, kapag i-designate natin ang stress na na-experience ng concrete as FCS and the modulus of elasticity na na-experience ng concrete equal to ECI, and the strain na na-experience ng concrete as the epsilon ES, so we can have this equation. So, ang FCS na makikita natin dito, ito ang stress na na-experience ng concrete element at the level of prestressing reinforcement. So, sa previous discussion natin, natackled natin na ang concrete ay nakaka-experience siya ng total flexural stresses. So, again, ang FCS dito ay flexural stress na na-experience ng concrete at the level of prestressing reinforcement. According to the Hooke's law, that must be equal to the product of the modulus of elasticity of the concrete. So, take note, since ang concern natin ay pretensioning, the modulus of elasticity of the concrete ay hindi siya equal sa modulus of elasticity of concrete at 28-day compressive strength. Kasi usually, ang prestressing force ay magta-transfer sa concrete even before the concrete attained its 28-day compressive strength. Since ang modulus of elasticity ay nakadepende sa compressive strength ng concrete, so therefore, there will be different magnitude of modulus of elasticity. Kung alam na natin or meron na tayong initial compressive strength ng concrete element at time of transfer, therefore, we can compute for the modulus of elasticity of the concrete at the time of transfer. And we can call that modulus of elasticity as the initial modulus. That is the case of the concrete. Pero pwede naman natin i-express ang equation na yan in terms of strain ES. So, i-bring down lang natin ang ECI as the denominator ng FCS. That's why we can have this expression. So again, just like the concrete, we know that the pre-stressing reinforcement is also elastic at the particular stage of pre-stressing. Therefore, pwede natin magamit or gamitin ang Hooke's law in an equation form. If we will signify the stress being experienced by the pre-stressing reinforcement at its shortens from this form, yung sa left end ng concrete, let's just call that delta FPES, the pre-stress loss due to the elastic shortening of concrete. And yung stress na yan is equal siya to the product of the modulus of elasticity of the pre-stressing reinforcement EPS times the strain being experienced by the pre-stressing reinforcement. But take note, for the case of the strain na na-experience ng pre-stressing reinforcement, since ang pre-stressing reinforcement at ang concrete ay already nagkadikit na, therefore, pre-stressing tendon suffers the same magnitude of shortening as the concrete. So, meaning, kapag ang concrete ay maka-experience ng deformation equal to the sum of these two delta ES, therefore, ang pre-stressing reinforcement ay pareho din siyang maka-experience or same sila ng magnitude na ma-experience in terms of deformation. So, in other words, magkaroon sila ng parehong magnitude of strain. Therefore, ang strain na ma-experience ng pre-stressing reinforcement that satisfy this equation, this delta FPES equals to EPS times epsilon ES is just equal to the strain na ma-experience ng concrete dahil same nga sila ng ma-experience na magnitude, which is equal to this FCS over ECI. Therefore, pwede rin natin i-substitute itong expression na to, itong delta FPES equals to EPS times epsilon ES. So, kung i-substitute natin yon, magkakaroon tayo na nitong equation na to, itong delta FPES equals to EPS times FCS over ECI. Or, if we will just try to express this ratio of the corresponding modulus of elasticity of pre-stressing reinforcement and the concrete element itself, so, i-designate na lang natin itong ratio as variable n, which is what we call the modular ratio. So, that is the modulus of elasticity of the pre-stressing reinforcement and the concrete element. So, kung i-designate natin ang modular ratio, retain FCS lang. Therefore, we can find the formula for finding pre-stress loss due to the elastic shortening of concrete, which is equal sa equation na to. Itong delta FPES equals to EPS times FCS over ECI equal N multiplied by FCS. So this is the flexural stress diagram acting on the concrete element specifically at the midspan. So this is formula for extreme flexural stress at the top. Itong FC equals to negative P over AC plus PE times CC over IC minus MC over IC. And FT equals to negative P over AC minus PE times CT over IC plus MCT over IC at the bottom. And this is actually the total of the several flexural stresses na makikita natin dito. So, kung hahanapin natin ang corresponding flexural stress acting on the same level ng pre-stressing reinforcement, so ang magamit natin ng formula is itong nasa baba or itong at the bottom. Since ang pre-stressing reinforcement is nakalocate siya below the centroids or the neutral axis ng concrete element. In other word, since ang pre-stressing reinforcement is located sa pre-tension zone of the concrete element, so magamit natin ang itong formula for the stress acting on the pre-tension zone. So, ano ang pre-tension zone? So, ang pre-tension zone, ito siya is a zone on the concrete element na nakaka-experience ng tension as the concrete supports its own weight. So, sa paggamit ng formula acting on the pre-tension zone, so kailangan lang natin ibahin or i-change ang magnitude ng C kasi alam natin naman na ang C stands for the distance mula sa centroids or the neutral axis papunta sa fiber that we are considering to find the flexural stress. And since the location of the fiber that we are concerned, which is at distance E from the centroids of concrete element, so palitan lang natin itong C as equal to the eccentricity. So ang maging itsura ng formula natin is equals to FCS equal negative P over AC minus PE times E. So ito na yung pinalit natin sa C over IC plus ME over IC. So, ginagamit ang formula na to for
ang M
finding
naman
the
will
stress
still be
acting
the
on the
moment
concrete
due to
at
the
the level
dead
of
load
the
alone,
pre-stressing reinforcement
along the
or
self-weight.
yung sa
Since we all
pre-tension
know
zone.
that at this particular stage of pre-stressing, the bending moment acting on the concrete element along the length of the concrete element, specifically at midspan, is just equal to the moment due to the dead load because there is only load na kinikerry nitong concrete natin. So, ang P na makikita natin dito is equal sa expression na to, itong delta P sub R from the time of jacking to the time of transfer.
There are two methods of the pre-stressing, the pre-tensioning, which was discussed earlier, and the second one is post-tensioning. So again, in pre-tensioning, elastic deformation of concrete will happen. So tendons are tensioned prior to the pouring of the concrete or prior to the concrete hardens. So that's why at the time of transfer, of course, these tendons will exert a compressive force on a surrounding concrete, and there may be elastic deformation of the concrete due to which losses will happen. But in case of post-tensioning, there are two cases. So as first, there will be no loss due to elastic deformation if all wires or all tendons are tensioned simultaneously. But if the tendons or wire are tensioned one by one, of course, there will be loss in the pre-stressing due to the elastic shortening of concrete. Relaxation of stress in steel happens in both cases. Shrinkage of concrete also happens in both cases. Creep of concrete also happens in both cases. Then friction losses only happens in post-tensioning because in case of pre-tension member, tendons are tensioned prior to the concrete get harder, so there are no issue of friction. But in case of post-tensioned, the cable or tendons are passing through the duct. Of course, while tensioning a cable through this duct, there are friction, maybe or may happen between duct and duct wall and tendon. So it will result into the loss or the losses in initial stresses. Anchorage is only happen in case of post-tensioning. And that would be all. وبالله التوفيق والهداية وأنتم بالخير وشكرا.